Oh, hi, Mr. Precella. We're back, continuing our discussion of logarithms. Right now, we're going to use our calculator to find the common log. Common log means log base 10, and it's the LOG key on your calculator. Your calculator has an LOG and an LN key. Notice how they write it in capital letters so you can read it easier. But when you're typing in my math lab, use lower. So let's see. If I haven't insulted your intelligence, I'm about to. Hit log 64, and I'll close the parentheses and hit enter. And it says round to 4 decimal places. So let's see. Counting up 4 decimals. 8, 1, 2, 3, 4. So that 1, is that going to be a 1? Or a 2. You look at the 7, and if that digit is 5 or larger, you round it up. So I'm going to type in 1.8062. 1.8062. There. Okay. We'll head on to the next question. And it says, find the logarithm using the change of base formula. Well, what on earth is the change of base formula? Well, looking at my calculator, there is no base 4. We either have the log base 10 key, LOG, or the log base E key, LN. To punch in log base 4, we're going to use something called the change of base formula. Let me write that down. Okay. Change of base formula. Change of base formula. Log base B of x. You can use either key. It doesn't matter as long as you're consistent. You can use the LOG key or the LN, but it's log x over log B, or if you'd rather use the LN key, it'll get you the same answer. As long as you're consistent. Don't use LOG and on the top and LN on the bottom.
I prefer LN because natural logarithms are what are used in a calculus environment. Rarely do you ever see the common logarithm, log base 10, used. It's all done in terms of natural logarithm for business and scientific purposes.
Okay, so, but whichever key you want to use on your calculator, let's see, what's that problem?
I'm switching. Let's see. Log base 4 of 18.
So we're doing log base 4 of 18.
4 to what power gives you 18? But 4 squared is 16.
So it's going to be 2 point something, right?
Right. Because 4 cubed is 64. That's way too big.
So with this change of base theorem, you can punch it in either way. You can go log 18 over log 4. Or if you go LN 18.
Oh, wait. I forgot to switch.
Okay.
I'm sorry.
Okay.
I'm falling down on my job.
If I'd gone log 18 over log 4, or you can use LN 18 over LN 4. It'll give you the same final answer. Now, you got to be careful with these. When you hit LOG and LN on your calculator, it probably opens parentheses. You've got to make sure you're closing them. As I mentioned a while ago, get into the habit of closing the parentheses when you...
Let's try it.
Yes.
Okay, let's try. What do y'all want to try? LOG or LN?
I say let's do both of them.
Okay, let's do both.
Okay.
LOG, it opened the parentheses. So I'll put the 18. And then I close the parentheses.
Don't close those parentheses, you're going to get the wrong answer.
Divided by LOG. It opened the parentheses. I type the 4 And this model calculator, if I don't close the final parentheses, it won't give me an error, but some calculators do. So as a former, because of my programming experience, I have an aversion to dangling parentheses. If I open a parenthesis, or if a parenthesis is open, I'm going to close it. And
so instead of typing it in, punch it in with the LN, Tim.
Let's see.
Yeah.
LN 18, it better be the same thing, right? Close parentheses, divided by LN 4, right parentheses. It better be the same number, so let's see. Y'all think it is? Sure enough.
It is. So let me write that down so you can. Oh well, you don't need to write it down. Just let's look and see. How does it sound to round to 4 decimal places?
Round to 4 decimal places, so that'd be a 2.08. Does that stay a 49 or does it go up to 50? What do we look at? A 6. If it's 5 or bigger, you boost up, so that 49 becomes a 50. 2.0850. And let's check.
I'm just going to move that arrow out of the way. Let's see. This is called the change of base formula. And why do we use it? Because our calculator doesn't have a base 4 key. It only has a base 10 and a base E. Let's see. There's another one. Okay. Log base 2 of 0.11. Log base 2
Can you move that?
of 0.11. Up we go. There. Well, since Tim prefers LN, we'll just do it with one of them. You can use either LOG or LN. And one thing you need to remember is which number goes on top and which number goes on bottom. Well, the subscript, the lower number, is the one that always goes on the bottom. Okay? The number that's higher up in the air, like the 18 or the 0.11, that's what goes on the top. But be careful. What I've written here is not what we're going to punch into the calculator because it'll open those parentheses, so we've got to be sure to close them.
Okay. Well, suppose we didn't.
Let's just try. Let's see what happens. We have time.
Well, first of all, let's punch it in the correct way. LN 0.11, close parenthesis, divided by LN 2, close parentheses. Okay, that's what we get. Try we did it.
Well, let's go ahead and do it the wrong way.
Yeah,
let's
see. Suppose you don't close those parentheses. Now, a few calculators do not open parentheses, but most of them do. Suppose we don't close the parentheses. Are we going to get the same answer? Not even close.
So which one's right? Well, I'm telling you it's the top one, the negative 3.18. Let's punch that one in first.
Negative 3.1844. Rounding to 4 decimal places. Negative 3.1844. There. And let's check.
If you had punched in that negative 1.804,
that would have been wrong.
Yeah.
Mm-hmm. If your calculator opens a parenthesis when you press LN or LOG, you have to type the argument and then immediately close that parenthesis.
Okay, well, one last problem.
And I think this goes back to the idea of inverses.
Yes. Here's a couple of rules. The exponential function e to the x, here's how we'll say it formally, and the natural logarithm function are inverses of each other. In other words, e and ln cancel each other out when they're side by side. Go to that calculator. So e and ln. Let's say we have e to the lnw. E and ln cancel each other out when they're side by side with nothing in the middle. Or it might be written with the ln first. E and ln cancel out. Those are inverses of each other. That's what you call two functions that cancel each other out, like multiplying by 7 and dividing by 7 are two inverse operations. So f of x equals 7x, and f of x equals x divided by 7 are inverses.
Okay, so let's go on to...
Let's see what the problem says. Okay, so let me get another sheet of paper. It says, given f of x equals ln x. So f of x,
let's keep these rules right here,
equals ln x. The first thing we're told to find is f of e. Tim, I didn't get the problem written down.
F of e to the negative
to
3.
the negative 3. Now
let me write down all three parts.
Okay, so there's the first part. Then the second part is f of
e to the ln 4.
E to the ln 4.
And finally, f of e to the 2 ln 4.
F of e to the 2 ln 4. Okay, let's see.
Okay, let me switch to the paper.
Let me see there.
Remember what we said about e and ln, the natural exponential and the natural logarithmic functions being inverses. So this is number 20.
So, let me relabel it. Problem 20. So to do part 1, part A, to find f of e to the negative 3rd. Well, remember with function notation, whatever's in the parentheses, you plug in for x. So we're going to have that blue ln, and in place of the blue x, we'll have e, the green, e to the negative 3rd. Well,
what did we just say about inverse functions?
You have the ln and e, they cancel each other out, leaving, in this case, just a negative 3. So that's the first part, negative 3.
Should I go type it in?
Yeah, go ahead and type it in. We're going to get finished early here.
Negative 3.
Okay.
Now the next one.
Okay. Now,
f of e to the ln 4.
Okay. Well, in place of this blue x, I'm going to put the red e to the ln 4. So I have blue ln. Maybe I spread this out too much. Okay, so I have the blue ln. I'm replacing this blue x with the red e to the ln 4.
Label that part B also.
Okay, yeah, this is part B. And here there's actually two ways you could cancel it. The ln and e here.
Leaving you with the red ln 4.
Or the e and the red e and the red ln could cancel.
Still leaving you with the blue ln and the 4. So you're still left with ln 4.
Whether you want to use this rule, canceling. Oh, wait, let me
just put it on.
It's a matter of whether you want to use this rule first, or if you not first, but just this rule or that rule. You can cancel the red e and the red ln, or the blue ln and the. I think I'll just do it like that, and write a red ln 4 as my answer.
So coming over and topping in. ln 4. And the last one. Switching back.
So here's part C. Well, I'm going to replace the blue ln.
No, you're not replacing.
Excuse me. I'm going to write down the blue ln, and I'm going to replace the blue x with all of this. So we have blue ln. In place of the blue x, we have the purple e to the 2 ln 4. Now, in this one, you don't have two options on how to cancel. You can't cancel the purple E and the purple ln because there's a number in between them.
Not consecutively, not being performed consecutively.
There, you can cancel those, leaving you the purple 2 ln 4.
So, common over
2 ln 4. 0. Again, that's an ln, not a capital I. You put a capital I, it's going to count it wrong. And it's not going to give you any sort of hint. Hey, you put an I instead of an L. But I guess that's enough for today. We have done a lot with logarithms, so hopefully y'all are caught up. And this weekend y'all should be working on this logarithm assignment. Okay? So y'all stay healthy.
Stay caught up and stay safe and stay healthy.
Yep.
We've enjoyed doing this today. It's been many months since we stood in front of this classroom.
But y'all take care. Let me stop this.
Bye.
Bye.